3, and those 3 are the ones that have proven through our testing to be by far the best and the most reliable. Some of the ones that were really, really tiny when it comes to the actual nozzle size, let's just say that the stepping motors would have blown themselves up if they could. So, because they kept on stalling over and over and over again. So, but for most of the other things that we have, the nozzles are going to work out quite nicely. The ones that we're going to be including with this.
So you get the same extruder body in the Pro and the Standard. This is it?
That's the apparatus. Yep.
Okay. And uses the same standard mounting system, so you just plug it in, same interface, all that stuff's good. And then what the difference is that, because we're trying to keep the cost down, the cartridge you get one and a couple of tips. When you get the Pro Pack, you get a spare cartridge and 3 extra tips for a total of 5. Is that right, or 6?
There's a total of 6. So
6, that's right. 2 of each kind.
Yeah.
2 of each size.
Yes.
So the sizes that come with that is 2 millimeter, and you're going to use it a lot with the stiffer materials. 1.5 millimeter, which you can use with the softer materials, and 1 millimeter, which you can use with things that are like RTV, things like that. And if anyone puts a special order in, I actually have a limited number of tips that have no hole in them for those of you that wish to experiment with making your own sizes. So that's so you got the visual aid. The Pro is just this and 2 of these and a handful of tips.
6.
And the Standard is this and 1 of these. So that's your Standard right there.
With 3 nozzles.
Yeah.
There you go.
Okay. So hopefully that cleared it up a little bit. Picture's worth 1,000 words, especially when it's a picture of a dessert.
Very true. So, no, I just wanted to say I didn't get a chance to thank Rafal or Les, but thank you guys for coming out.
Oh yeah, for sure.
For the class. So, I'm sorry. What? Go ahead.
It's kind of fun watching things print.
I know. They're watching us watching that.
Sorry.
So.
This is not going to be a long broadcast tonight.
No.
I can tell you we've been working like beavers every day, and it being a holiday, we try to keep in touch with everybody once a week. And we thought it'd be nice to show you the material sensor, and we thought we'd just print another one and throw it on there. By the way, I was just going to say that.
Great question, Powers. You say he asks same filament sensor on the engines and the systems.
We reviewed that today because we were going to actually print a filament sensor for the engine tonight.
Yep.
And then we looked at it and we said, if we make just a little tiny change in this, it'll work for both. And so I'm going to do that after the broadcast tonight. It just requires me going back to a Libre, and I just got finished assembling this, so I didn't quite do it before the broadcast started. I thought we'd just go with a file that we sliced before and knew what it was going to come out as. Not from a G-code standpoint, because we just sliced this one before I started printing, but from a physical shape standpoint. It's kind of a benchmark for us, because we're comparing the 2 different thicknesses and seeing how we like that, seeing how the head performs. I don't think anybody appreciates this fully enough, but when you're melting plastic, it becomes a liquid, but it's a viscous liquid.
Yeah.
And so once it goes through its glass transition temperature, it flows. But as you reduce the orifice size, it becomes really, really, really tough to get flow to go through the nozzle. And I don't think it's squared. I think it's a cube function.
Yeah.
It's pretty stiff. So that tells you that if I reduce the size of the nozzle diameter, it starts to put a lot of extra back pressure. So this is a big thing to print at a reasonable print speed with a small orifice size and have no problem with the motor driving it. To us, that was kind of the holy grail. And I was able to print with this orifice size 20 degrees C higher. And so we're trying to lower the temperature down to increase the viscosity to get kind of a print pressure safe operating zone that we can put in there and say you can print in these parameters.
Yeah.
One thing I am going to do with Hutch's permission is I will go through and demonstrate how you can change the material. because I don't think
Oh,
we've
yes,
done
yes.
that live, and I think that we've talked about it.
We've shown them the fact that when you go from one color to another color, that only, the only the smallest amount of material actually comes out, and that's coming directly out of the nozzle through the purge process. So if you wanted to run a couple different colors through your nozzle, I think they could. What do you think? In the middle of the build?
Let's get on the color thing another day.
Okay.
We got some great things planned, so I'm just going to leave that one for a surprise party. But what is more important is moving from ABS to PLA to nylon, back to ABS, back to nylon, back to PLA is not nearly as painful as I thought. But the other thing is splicing is not painful at all, not even this much. You just can't run to the very end of your reel.
Yeah.
What you want to do is stop about an inch or two above the end of the head and then pull it out while it's hot. And that way it separates right in the fusion chamber, and this will allow you to feed the next one in so it's deep in the exhaust pipe. So the exhaust pipe comes out of the motor, and it's actually an intake pipe, but don't tell anybody I said that. So the exhaust pipe comes out of there and goes right into fusion chamber. So the fusion chamber is hot, so when you pull the plastic, it literally separates right at the fusion chamber as long as the head is at elevated temperatures. It doesn't have to be at print temperature. It can be at 120, 100 degrees C, and it's just fine. So,
Les Music asks, sometime in the future it would be nice to have a do not print materials, a list of do not print materials, especially the hazardous to health variety. Yes. And in fact,
that's a tough one.
what?
It's easier to print materials that we have done, that
Yeah.
we do know is good. It's a smaller list.
Yeah.
If I leave off kryptonite, Superman's going to be mad at us. Okay? So,
Superman or Lex Luthor? I just think-
Superman.
Okay. I would say that when it comes to materials that you do not want to print with, one person who's near and dear to my heart asks me the other day if we could print with weed whacker wire, and I looked it up. Do not print with weed whacker line,
Or fishing line.
because even though it says it's nylon, do not print with it, because one of the outgases that comes from that particular by heating it up and using it like that is HCN, which is hydrogen cyanide. Not good stuff, guys. So you don't want to breathe that stuff in. But just but I'll put together a list as we come across them, Les, and put them out there on our website. So.
If anybody out there knows of hazardous materials that they've heard of people try, please
Yeah.
send it our way. We'll be glad to share that with people. But until then, we're taking the opposite approach. We're saying we've tested this. This is a certified material. Work with it under these parameters, these temperatures, these conditions. Must be exhausted. Doesn't need to be exhausted. Blah blah blah. So the idea is that we're sharing our certified experience, and believe me, it's a journey.
That's a nice way of putting it.
Well, I mean, I've been developing stuff for years, 35 years, and what we experience when we're able to change the design, print it, change the design, print it, change the design, print it, it's so much fun. I mean, it's really fun.
It's true.
So,
Powers USA, will the hot heads come with multiple tips or different orifice sizes? That's another good question. We didn't realize.
we have not discussed whether we're going to allow you guys to have multiple tips or not. It's certainly doable. Right now we have two sizes, 0.4 and 0.5, and the way I got the 0.65 was to drill it out. So we could prepare some of those possibly. Before this last revision, I was going to strongly suggest we do not allow people to change the tips, because making the seal on the Teflon was really tough. But an accident happened, and a miracle happened, and a moment of inspiration happened, and I remembered something from 25 years ago, and we ended up with a really nice sealing system. So I think it is viable for you to change the tips now. Let us test that, and if that's proves to be as we expect it to, because the reason why this one worked right off the bat was that it has that special sealing system. But this is my first try, or second actual try using it. See, what happens is, if I may be so bold, you're pushing the material down into the fusion chamber. So as it melts, it gets molten, and the part of it wants to come back. It's blowback is what we call it.
Yeah.
So any little crack, any little leak zone that you might have around the threads or up through the intake pipe, it just squirts out and bubbles out. It looks like the Beverly Hillbillies shooting for crude oil there. So it just blip, 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 blip. Okay. Well, you don't want that because you got this beautiful print. It's coming out. Next thing you know, every now and then a random blip drops on, and it's like, ugh. So
and you get this burn mark.
Right. You may not have known this, but 2 weeks ago when we were printing with that other head, we were testing the drive system and not worrying about the seal enough. So when we printed then, I was just making sure that the hob shaft had the torque that we wanted, and before that the hob nut. So we did have a leak in that system, and I actually had to wick off it with for a day or so until I got the Teflon tape to actually seal it. So it's not what I consider a user-friendly experience. On this one, we have a special sealing system, and it doesn't, I mean, it does it right now, and it does it pretty effortlessly on the part of the user. So this looks to be promising and viable for you to change the tips without a lot of problems. Someone says the tips are, Powers USA, tips are a wear item, correct? They should be replaceable. I agree with you that they should be replaceable. How much they wear out, I cannot say. I do not have enough wear time on a single tip. I end up throwing them away because I booger them up when I'm unscrewing them. So it sounds reasonable to me to think that they would be a replaceable item. That said, 2 weeks ago, I wouldn't have recommended that you replace them very often because the seal would create a nightmare for you. So, you know, I mean, we're just going down this list of things, and we're sometimes being surprised at something that hasn't been mentioned before. This is something I know now that I've looked at it, I mentioned it. Other people say, "Oh yeah, my tip leaked, my tip leaked, my tip leaked," and now we hear more about it. So these are little nuances that have been avoided.
And they've been avoided like the plague.
Not by us, but just avoided for whatever reason. So as of this time, I fully expect to have the tips replaceable. And wow. I think it's just finished. Now I'm going to actually probably start another print.
Okay.
It's 840. Yeah, I will.
Yeah.
And this print, I'm going to goose the material flow up by 15%.
All right.
But I'm going to turn this off and let it cool down for a minute.
Okay.
Let's just kill the heat lamp.
Okay.
And we can turn this on high.
Nice. Or air circulation system.
Yeah. We're going to blow the smoke around the room for a little while.
Yeah. The good material is certainly great. Thank you, Les. Yes. We will definitely do that. What you looking at?
I'm just inspecting it, you know, with no cleanup on it whatsoever. I just want to see what it looks like. I'm looking for uniformity. I'm looking for the gloss of the finish. Really, this came out pretty solid. I don't know if I want to add a whole 10% more or not. One thing that's obvious when we're looking at this is the start-stop is still not perfected. So we'll be wanting to work on that. The other one is we don't know what anomalies there are on the fill because from the slicer. When I look at this, it looks to me like I'm getting pretty close to perfection on the actual material going into it. As far as the amount of material that's being delivered.
Yes.
Let's see where we're at on temperature.
And Powers USA asks, that engine has the Beefier Z rail, correct?
It does.
Yes, it does have the Beefier Z access rail right there.
Oh, I would like to make a little announcement to people that care. Please, I care. That's what Luke Skywalker said. I'll do that in a minute. Wow, this just came right off.
Beautiful.
Now this is the glue that we use, and you can see it's just there. So it will come right off. One of the easiest ways is just to dip it in acetone. And then it just wipes right off because it just redissolves real quick. But this is hot, and I don't want to put this in the hot acetone just at this second. One thing you can see, you'll see it's pretty straight. And I think you can line that up. So this has come off, and warpage is not a big issue. It does have some fill spots in here where it did not adhere. I don't know if you guys can see that yet. Guess I'm taking it up. There you go. Wow. Talk to the hand. Sorry guys. We'll have to get the microscope and hook it up for here. But overall, I mean, it's not bad. It's not fantastic. It will work as a material sensor. So, you know what I'm tempted to do? Probably not. This was a good print because it has inverted overhangs and things like that. We should also drop the temperature down on this by 5 degrees.
Really?
Yeah. Yeah.
Okay.
I'm thinking that not the build platform, but the actual build temperature. I'm thinking a lot of these spider guys will go away when we do that.
Okay.
I don't know. This is something we're not sure of. And some of this is the slicer starting randomly. See this start stop? What we should do is get the microscope and hook it up so they can see better with it.
I can do that. Hold on a second.
Can you run both at the same time?
I think I can. Give me one moment.
You sure you won't lose your broadcast?
I'm sure. I'm going to need to get your extension cord though. Your extension cable.
Which one is the one? I don't have an extension.
It's the USB.
Oh, yeah. I do have an extension cable. There you go.
All right, guys. Give me just 1 second. I'll hook it up so you guys can take a look at it underneath the.
Well, I can load it up over here. I can pound it in the chuck.
It's okay.
Well, this way it'll be steady.
I know, but this way they'll get.
Oh, it won't
direct.
reach. It won't reach.
Yeah.
Okay. Sorry. I thought it would reach. Okay. See. Oh, look. This is not good. It's not the view we were hoping to give you guys tonight. Here.
All right, guys. Oh. Okay. Should be up and running in just a second. So, guys, forgive me. Give me just 1 second. This is a special attachment. This is one of the accessories that I was talking about. That it's not quite ready for prime time because we have got a little bit more documentation to do on it, but it does work, and I'll prove it to you guys in just 1 second. So, and now it's ready to use. And let me go ahead and. The screen's going to go black just for a second, guys. Don't panic. It's just me adding this camera in. Okay.
But you won't lose the microphone?
No.
It looks like it's still up and around. That's good. Yeah. I see the microphone still.
Okay. That is the camera.
Nice. Oh, well, you want me to get? Yeah, I got the stand for it. It's right over here. Yeah.
Uh-oh. Ah. There it goes.
Yeah.
Ah. This is the problem with this particular USB cable. Yeah. There we go. Okay. All right.
So let's take a quick look around here. Now you see the spiders that are on there, and I'm actually going to bring this up a little bit so you have a little bit more of a bird's eye view. Almost too much magnification. And look at that. Okay. So again, you see the voids that are in there, those two little voids. Got a pencil? There, I'll show it. Right. This is kind of tough to do. Right there, and then right
There.
over here. Those are slicer defects, so we have to work that out. But if you look at the exterior here, you see how beautiful and solid the lines are. So that's telling us that we're having very good flow, characteristics, all that. There is a separation point right here. That's again the slicer. The spider lines that we see, these are caused by the start-stop not being crisp. They come right off in most cases with just scraping them off. And I need to get this, and oh, you know what? I do. Hold on a second. I'll be right back.
Okay, there we go.
I'm using it for a minute.
Okay.
Not 2 seconds. Not 1 minute.
What? Excellent. So yes, guys, that is one of the accessories that we've been looking at, and we've actually been using this quite a bit on our own semiconductor products. So that's one of the reasons why, when it comes to 3D scanners, we took one look at it and we said, you know what, this is very easily doable. So, and when it comes to getting higher res, it is even more possible when it comes to doing inspection and stuff like that. So, but if I can be so bold, just for a second. Alright. There is the inspection system that we're using. This, as you guys can see, small little gib tool. This is the collet that we have. Fits right on in. It's got your lock screw. This part goes into here. Fits on your system. And that's the reason why, when it comes to the USB, that from this guy on that side, that's the reason why we're trying to get the USB hooked up on the top of the engines and also the systems, so that this, when you plug it in, talks directly down to your PC that you have inside of your engine or your system. So you can get high resolution pictures directly piped in to your PC that's down below. So there you go. Alright. Wow, I need to get a haircut. There we go. Okay, so one of the things that happened this week, if you guys did email me and I haven't gotten back in touch with you, I apologize. It's been absolute pure madness around here in order to get everything ready for not only for what we were trying to do this past week, which was number one, to ship all the other products that we had for the semiconductor industry, because we had an order that came in. We had to get those guys out the door, which they went out the door on Saturday, but also doing all the stuff here for the class and getting ready for the class as well. So we know what we need to do a lot more of when it comes to the class. We gave a lot of detail in the class, probably too much, as Yeoman will probably say as well, and I apologize for that. Yeah, so it's a refining process. And then let's see. Thanks, Yeoman. Les Music says, I don't exactly remember how many heads to expect, but I definitely want a thin, hot end pro set. Okay. Alright. Yeoman says it was good to see the machines. So.
Yeah. Okay, so here's the deal. This hole is for an 1/8 MPT, which is a tapered thread, and it's pretty fine, so printing that thread would be a little bit tough. But one thing we did was we designed this with a taper cylinder in it that has 5 layers of solid plastic surrounding it. So I'm actually going to tap it, and I'm going to let you look with the microscope inside the bores. As long as I'm tapping like a maniac.
Yes.
So you saw it live on TV here, and if we were printing with voids around this part of the circle, it would show up big time in the threads.
Yes.
So let's get this,
Okay, hold on.
let's try to set this up here.
There we go.
Okay, now let me just focus in. There you
There
go.
you go. Nice.
Yeah, I'm going to actually open the bore up a little bit. I'm going to turn this down. Don't worry, we're going to actually,
No need to adjust your television set.
there you go. So if you look how solid those threads are inside there, I actually installed these and I'm using a wrench on it, and they turn out just absolutely
Beautiful.
fantastic.
Yeah.
So there you go. Look how nice and solid and smooth they are. And you can see how easy it was for me to insert those threads. So Yeah, you can go back to regular
Okay.
thing. Sorry, guys. There is a reason for having a microscope. Part of it is just for that very thing that we just talked about, inspection, and part of it is to have a high resolution documentation on some of the feature sizes. So, for instance, if I was trying to see what my feature size was like at different temperatures, I could zoom in, and here's a good example. Go ahead and pop that in there.
Okay.
So I'm going to go up on this,
Okay.
and then I'm going to zoom out. Alright, so these are holes that were built on the side. So you do it by,
Focus a little.
yeah, a little out of focus, sorry guys. There we go. So when you do this, you'll see that it has to jump over the hole. It's building it, and then it drops or jumps up over top. I have this turned sideways. So actually, the way it was built for your screen from bottom to top is like that.
Well, almost.
Yeah, it's like that. So you can see what's going on is it's building over space, and we have a few threads. Now the spider threads, they go away. So all we do is chase this with a drill bit. These are very small holes. They're only 80 thousandths of an inch. And we actually put an M3 or an M2.5 screw into these. So they're very small. But it lets me see what's going on and see what defects are happening. So I enjoy having that available. Again, don't mind the Krusty the Clown act. We put some other solvent on here just to see if it would dissolve it. It didn't do such a good job.
No.
So, see, it's part of our learning process. Don't worry, this sands right off, so this part isn't lost. I just thought we would try one of the chemicals that we were told would work.
Did you just try that in the other room?
I did.
Okay.
I was trying to clean it off with the acetone, but it makes a bigger mess.
Yeah.
So we didn't try the boiling acetone. I'm trying not to use that here because it's not, it's kind of a residence at times. So we try not to boil the acetone at home.
Yes.
Anyway, so there you go. That's tonight's thing, and you can have a shot at that. So.
Nice. Okay. So does anybody have any questions before we continue on over anything that you've seen so far tonight? No? Alright.
Oh, I do have an announcement. About the wider rails, now that I read it.
Yes.
This bill was 0.4 millimeters, so 16 thousandths of an inch per layer. We're going to do another one at 200 microns tomorrow and give that an evaluation. Again, we're just testing out the new head. We want to see what the limits of are. And we'll be glad to post pictures online. And on our next broadcast, we're going to have a wider suite of things to do. Would you guys like to see how easy it is to take the material out? I think you would.
Yeah.
Tell you what, I'm going to start heating the head because it's cooled off already. And I'm going to start heating the head. It takes about a minute. And then I'm going to give you that exciting news about the wider rails.
Excellent. So, thank you, Powers USA, for asking that question. What the layer thickness of that build was. So, okay. This guy. Heating up?
Yes,
Yep.
now it is.
Okay.
Have to watch that thermometer. Okay, so here's the exciting news. I'll do it from the captain's chair. You can see the huge mess behind us. We are like all over the place right now, so forgive us. This is after cleaning up. When we first went and asked you guys if any of you would like to have the wider rails, we were thinking we were going to have to pay very small quantity parts, but because IKO has been such a great loyal supporter to us, they have agreed, and this is as of Thursday afternoon of last week, so that's why no one's heard about this. They have agreed to give us much better pricing on the wider rails. So anybody who got a System 30, and if you've paid for it, don't panic, we will give you your money back for what you pay for a wide rail, or we'll give you some other goodies or credit toward it. You pick what you want. The System 30s include a wide rail. There's no upcharge for a wide rail. The System 30s will only